Welcome to the course on forest mensuration. As the course title suggests that it is the measurement of forests and forest resources. Now, before we come to the main course on of forest mensuration, let's learn about the scales of measurement. Measurement of scales are used to categorize and quantify different variables. There are basically four scales of measurement: nominal scale of measurement, ordinal scale of measurement, interval scale of measurement, and ratio scale of measurement. Now, before we learn something more about in detail about these levels of measurement or the scales of measurement, let's know something about the properties of measurement scales. Now, each measurement scale has to have at least one property of the measurement scales that will enable it to qualify for the scale of measurement. The first property of measurement scale is identity. It must have a unique meaning. Like if we are measuring height, height has some meaning. If we are measuring weight, weight has some meaning. If we are measuring temperature, temperature has some meaning. Likewise, when we apply these kinds of things in forests, we have forest biomass, we have tree height, and we have certain similar things which are applicable in terms of forestry. The second property is magnitude. Now, when I say about tree height, it has to be something, say 2 meters, 3 meters, 5 feet, 10 feet, or anything like that. So it got to have something which is called as magnitude. There is a third property of measurement scale called as equal intervals. Now, when I say 5 meter height, and then there's another plant which has 6 meter height, so then there is a third plant which has 7 meter height. If you see the difference between 5 and 6, it's 1. And if you realize that the difference between 6 and 7 is also 1. So each successive unit has an equal interval between them. Likewise, it is given in the slide that there is an equal difference between 1 and 2 and an equal difference between 19 and 20. Now, the third property of measurement scales is a minimum value of 0. So the height can be 0, age can be 0, mass can be 0. So this is also one of the properties of measurement scales. Now, depending on how many properties of scales does any scale have, will let us know which type of scale is going to be that, whether that is going to be a nominal, that's going to be an ordinal, that's going to be an interval or ratio scale of measurement. Now, coming to nominal scale of measurement. As you can see, this scale of measurement satisfies only the identity property of measurement. It has only identity. Now, if we have to say whether any person is a male or a female, we can just say whether he is a male or a female. That's his identity. We cannot say that he is less of a gender or more of a gender. There is nothing like that. Or ethnicity, or the country, or color. We can say the proper color of that person, and we can't have anything other than that. So this is the nominal scale of measurement. It has only one property of measurement, that is identity. Now, coming towards ordinal scale of measurement, this scale of measurement has both identity as well as magnitude. And if we all of you must have this seen or watched derby race wherein horses race against each other. Now, if there is a white horse, there is a brown horse, there is a black horse, and the brown horse wins the race. So and the white horse comes second. So we can say the brown horse came first and the white horse came second. we can't just say that it was a close race or the one horse won by a mile. So this scale has both identity as well as magnitude. Identity is the brown horse who won the race, and its magnitude is that it came first. So this is how ordinal scale of measurement has identity as well as magnitude. Now coming towards interval scale of measurement, this scale of measurement has three properties from the properties of measurement, which is identity, magnitude, and equal intervals. Now, about the identity and magnitude, you already got an idea. About the equal intervals, I tell you, if we measure temperature and we record a temperature of 40 degree and 50 degree, and the next morning we measure the temperature which is 50 degree, and after an interval we got the 60 degree. Now the interval between 40 degree and 50 degree is equal to the difference between 60 degree and 50 degree. So on different days, if we record temperatures, there is equal intervals between the graduations that scale have. Other examples of this interval scale of measurement include time of the day, that is 2 p.m. and 4 p.m. It has a difference of 2. 6 p.m. and 8 p.m. it has a difference of 2. So we can call that as equal, having equal intervals. And the other examples may be year, and just like 1998 and 2000, the difference is 2. 2000 and 2002, the difference is 2. IQ scale, Likert scale. So this is about interval scale of measurement. Now coming towards ratio scale of measurement, it possesses all the four properties. All the four properties of measurement, that's identity, magnitude, equal intervals, and a minimum value of 0. As you already know, that when a seed germinates, the plant doesn't have any height. When it starts germinating, it starts attaining height, starting from the 0. So it has identity, which is height. It has magnitude, which may be 0.1 centimeter, 1 centimeter. It has equal intervals, like 2 centimeter is followed by 3 centimeter, followed by 4 centimeter, each having an interval of 1. And it started with the minimum value of 0. That is, height was 0. Then when the seed germinated, it attained a height and started from 0. Likewise, you can have mass. Mass can be 0. You can have age. Age starts from 0 when a person is born. He doesn't have age at that time when he becomes an hour old, and a day old, and then a month old, and then a year old. So this is how ratio scale of measurement has all the four properties. Now basically, overall, if you see this these four levels of data measurement, they are qualitative. The nominal and ordinal are more or less more of qualitative category, and interval and ratio scale are more of quantitative category. Now the units of measurement, a unit of measurement is a definite magnitude of a physical quantity defined and adopted by convention or by law, that is used as a standard for measurement of the same physical quantity. For example, length is a physical quantity. The meter, is a unit of length that represents a definite predetermined length. And when we say 10 meters, we multiply that meter with 10 times so that we get 10 meters of length. And there are, as you already know, you must be acquainted with all these 7 SI units, which is the ampere, kilogram, meter, second, Kelvin, mole, candela. All of them, not necessarily, but most of them you're going to use in your forestry. These are SI base units, which were formally agreed in the Conference on Weights and Measures in 1960. There are some other units which are the units which are derived from SI units. You can say area, which is square meter. They are derived from the basic SI units: volume, speed, velocity, acceleration, and many others that are given here in the list. These are the SI derived units. You may find them anywhere and use them anywhere in your course on forest mensuration. Now, when you write numbers, you might come across with very large numeric values. Just to avoid those large numeric values, there are some prefixes that are used. You must be already knowing these things, but just to refresh you, these may be iota, 10 to the power 24, zeta 10 to the power 21, exa 10 to the power 18, and kilo, you already know this one, 10 to the power 3, micro 10 to the power 6, pico 10 to the power minus 12. This micro is 10 to the power minus 6, pico is 10 to the power minus 12. So from here, you go from positive and towards negative, and yocta is 10 to the power minus 24. So you got to make your work easy by using these prefixes. Thank you.